what it means to plot points on an XY plane. Any questions at all? I don't want to like go over this if everybody's okay with this. Everybody all set with this? Yes, no? Thumbs up, flags up, everybody? Okay. Yeah? Anna? Not now, but we will. It's going to be, if you look on your schedule, you'll see a section called lines and slope. So we will be getting there. Okay? All right. But just in terms of plotting points, we're all set? Okay. All right. So why do we graph equations anyway? Well, we like to sometimes be able to see, get a picture of what we're looking at when we look at an equation. And it's a visual representation of the algebraic or the symbolic view of, in this particular case, here's what we call the symbolic view, y equals 4 minus x squared. We would like to have a visual of that equation. So one thing you notice is that this equation has two variables. So a solution to this equation will have two parts, a number for x and a corresponding number for y that makes that equation true. That's what a solution to this equation is. It's a value for x. We plug that value for x in and out pops a y. And so those two come together. They're called an ordered pair. All right. So today we're going to take a look at a few ways to generate a graph. One is by hand, which you've probably done before. One is going to be with a graphing calculator, and then the other one is going to be with the program Geogebra. So let's take a look at this, and we're going to do this by hand first, and then I'm going to show you how to do it with a graphing calculator, and then I'm going to show you how to do it with Geogebra. So those are the three things we're going to do today. All right, so let's take a look at this. So if I asked you to graph this equation, one way you do it is you graph enough ordered pairs, which are solutions to that equation, so you get an idea of what the shape of the graph looks like, so you can just connect your dots and throw in some like arrows at the end of your graph. Okay, but some of you before you start may know a little bit about the shape depending on how much you remember from your previous math classes. So if you looked at this equation, is this equation going to have a picture of a straight line? Why not, Sam? Oh, he already knows it's a parabola. Why isn't this going to be a straight line? What's the clue right away? Yeah, Will? Yeah, because x is squared, right. A linear relationship only has x to the first power. So then we learned that anything that has an x squared as your highest power should have the shape of a upside, a U like this with the arms up, or a U with the arms down, or a parabola. We call that shape a parabola. Okay, so we got an idea of what this is going to look like, but in order to do this, we're going to generate some points. So the first point I picked on here was the x value being 0. So here I am right here at 0, and I'm trying to figure out what's my partner's name, what's my y value. So to do that, to find my y value, I throw 0 in for x, I square it, and I subtract it from 4. So when x is 0, y is 4, and we write this as the ordered pair 0, 4, and then we plot it right here. Okay, there's 0, 4. Okay, so remember 0, 4 is a point on this, what we know now is a parabola. It is also, this also represents one solution to this equation. It's just one solution. How many solutions does this equation have? In this particular case, we might find 1, 2, 3, 4, 5, 6, 7. But in general, for an equation like this, how many solutions does it have? A lot. Yes. What's another word for a lot? Infinite, right? There's an infinite number of x's I can put in there because the domain for this equation is all real numbers. This equation doesn't have any denominator that we have to worry about. Remember in Monday's class, we said if there's a denominator that has an expression like x minus 2 in it, then we've got to be worried a little bit about making the denominator 0. Well, this denominator is 1. No problem there. And there's no even roots. So the domain for this, the domain is all real numbers. So that means I can pick any number on this x-axis from negative infinity to positive infinity. So I have an infinite solution set. Well, we can't graph every possible point. That's impossible. So we're just going to pick 7 of them and graph them. So let's do this first one. When x is -3, let's find y. So we put -3 in for x. We put that in parentheses because it's a negative number and we square it. So this becomes 4 take away 9, which gives us a -5. So when x is -3, y is a -5. So let's plot this point, -3, -5 on our graph. So I go to the left 3 and I go down 5. And I label it -3, -5. Okay? Everybody okay with that? Okay, let's do -2. So the next one, 4 minus a -2 squared equals 0, because that's 4 minus 4. So at -2, I have 0 for my y coordinate. -1, 4 take away a -1 squared is 4 take away 1, which gives us a +3. So our point is -1, 3. So I go to the left 1 and up 3. Okay, so if this is a parabola, it means it has symmetry. So if I go to the left of this, well, we'll do that later. I can sometimes get ahead and want to tell you too much. Okay, so when x is 1, let's get that point. 4 minus 1 square is 4 take away 1. That gives me 3 as well. So I have the point 1, 3. There we go, 1, 3. And 4 take away 2 square is 4 take away 4, which is also 0. So I'm at the point 2, 0. And then finally, I have 4 take away 3 square, which is 4 take away 9, which is -5. And that's 3, -5. So 3, -5. Okay. So right now, if you have never had an experience with connecting these points, you might connect them with like straight lines because you don't know. But these aren't straight lines between these points. In other words, as you go from -3 to 5 to -2, 0, it doesn't go up at a constant rate. You know that a parabola is this kind of smooth, curvy looking thing. So just do your best. I kind of always start right up here near this highest point and I make my little U-turn there. And then I kind of come down like this and aim for that. And then always put an arrow because this graph continues to go down forever and ever. And then just connect this down like this. Okay. So that's pretty much what this equation looks like if you were to graph it. And one thing that's always good to do, just like you would never look in a paper and see any type of graph in the paper without a title, you need to put a title here. And the way you do that is you just label your graph with the equation that it represents. So always label a graph with an equation. Okay, that's a way that you tell me or yourself later on when you're looking at it what it looks like. So there's some special points on this graph. One is the very first one we graphed, the 0, 4 point. Does anybody know what we call this point 0, 4? It's called the y-intercept. And the y-intercept is the value for y when x is 0. It literally sits, the point sits right along the y-axis. Okay? And given that the shape of this is a parabola, does anybody know another name we call that point when it's on a parabola in the position that it is right now? It's the vertex, yep. So another name for this particular one is a vertex. And pretty soon we're going to be learning another name for this vertex. It's called the maximum value of this equation. So we say here that 4 is the maximum value. In other words, there's no other point that's ever going to be higher than 4 or have a greater value than 4. Every point, whether you go to the right of x equals 0 or to the left, will always be less than the y value at 4. So no other point will have a y value bigger than 4. So it's called the maximum, 4. We're only interested in the y value here when we talk about maximums. 4 is the maximum value. Okay. And then similarly down here we have some other points that actually sit right on the x-axis. Okay, and these are called the x-intercepts. And these are the values of x that you get when you set this equation equal to 0. So that's what we call solving a quadratic equation. You set it equal to 0. And these would be the two values of x, positive and negative 2, that satisfy it. Okay, so what I'd like to do now is I'd like you to graph at your seats. I'd like you to graph the absolute value of x by plotting some points, generating, 7 pairs of points, plotting them, and then connecting them. Once you've done that, would you please put the flags up so I know when you're finished? And if you have a question, just let me know. I'll be glad to help you out. Okay? You should have something on your paper that looks like this. Oh, I think I was recording that whole time as I was walking around, so you'll hear all the little conversations. Okay, so this is a picture or a graph of what we call the absolute value. Okay. Notice I have it in two different colors. And I spent probably more time than I should have in my first class going over the definition of absolute value and how it relates to this. So I'm going to hang on to that because then I was rushed for Geogebra and it was kind of a disaster. So I'm just going to let this go. Does anybody have any questions on graphing the absolute value? Any questions at all? Okay. I think I went around and just about everybody got there, got to that graph. So if we want to find the x and y intercepts of a graph, we've already talked about this. Okay, you want to read this for me, Christopher? The x-intercepts, start there.
The x-intercepts of the graph are places the graph crosses intersects the x-axis. Similarly, the y-intercepts of the graph places the graph crosses intersects the y-axis.
God bless you. Okay, so let's identify the x and y axis from each of our two examples we had. So our first example was the graph of y equals 4 minus x squared. And our second example was y equals the absolute value of x. So what were the x-intercept or septs? Sometimes you have 2, sometimes you have 1, sometimes you don't have any. So in our first example with the equation y equals 4 minus x squared, what did we get for our x-intercepts for that one? Yep. Negative 2 comma 0 and 2 comma 0, right. And what about for the absolute value, which is right here? What did we get for the x-intercept? 0 and 0, right. 0, 0. Okay. All right. Now the y-intercepts are the y-intercept is where our graph crosses the y-axis. So if we scoot back real quick to our first picture, the y-intercept here is Katie. What's that one? Yeah. Okay, I forgot. There's two of you. So I'm going to call you Katie and you Caitlin. Is that all right? Just because there's two of you. What's your real name, Katie? You're Catherine. Okay, so I might call you Catherine. I might call... Oh, you don't respond. All right, then I know this Katie will respond to Caitlin, right? Otherwise, I'll say... All right, I'll say Katie W. All right, she'll be Katie W. Oh, for crying out loud. Okay, two Katie W's. All right. All right, I don't know. I'll look at you and point or something. I don't know. We'll figure it out. All right. All right, so the y-intercept on y equals 4 minus x squared was 0 comma 4. And someone else, let's see. Hannah, do you want to tell me what the y-intercept is here? Yeah, so this particular graph, the absolute value, both the x-intercept and the y-intercept are exactly the same point, 0, 0. Okay, we could have found these points algebraically. So if we want to find the x-intercepts, oops, that moved on me. If we want to find the x-intercept algebraically, then how do we do that? How do we find the x-intercept algebraically? Well, let's take a look at these three x-intercepts here. What do they all have in common, all three x-intercepts? Katie? What zeros? The y value. So if I wanted to find the x-intercept algebraically, I would take my very first equation, 4 minus x squared, and I would put a 0 in here, and I would solve this. Okay? And how would I solve this? Well, that's why we learned factoring the other day or reviewed it. We would factor this because this is the difference between two squares. And remember, that was the really nice factoring form where they kind of looked identical, but one was addition and one was subtraction. So don't let the fact that there's a constant there as your first term mess you up. You just put 2 in the first slot, x in the second slot, and then you do your plus and your minus. Now you set each one of those factors equal to 0. You want to know when does 2 plus x equal 0, and that's when x equals -2. So that's this x-intercept right there. And then you set this second one, 2 minus x equal to 0, and that equals 0 when x is +2. And that's your second intercept, x-intercept on that graph. And for the absolute, for your other equation, y equals the absolute value of x. Again, you substitute 0 in for y, and you say, what x value, what must x be so its distance from 0 is 0? Well, the only answer here is x must be 0. Okay. So that's how you do it algebraically to find the x-intercept. And then the y-intercept is when your x is a 0. And you just plug into your formula, into your equation, x 0, and out pops the y value for your y-intercept. Okay, so here you put 0 in for x, and out pops y, 0, 0. So that's how we do it algebraically. So you can get it from looking at the graph. You can get it algebraically, okay? And you'll see today how we can do this with Geogebra and your graphing calculators as well. Okay, so sure, yeah. Any questions on finding x or y intercepts for a graph? Okay, so you'll have some practice doing this in your homework as well. Okay, so let's move along. So now pull out your graphing calculators. Jesse, do you still need that screen up?
Yeah.
Okay. Yeah, there you go. Just let me know. Okay. So the only types of instructions we're going to have really are for the TI-83 Plus, and the 84 we can work with. Some of you have, I just got these calculators like in June, so the yellow ones are the 84s, and some of you have the black ones, which are the 83s. If you're using something different, I can't help you with instructions. So I won't be able to tell you how to graph on that particular one. So you could come grab a calculator if you want, Katie. If you remember, that's great. Then you can teach me. How's that? Is that a Casio?
No, I can see I Inspire.
Oh, an Inspire. That does everything. Ah, all right. So remember, on your exams, you'll only need a scientific calculator. That's just your basic calculators with, your exponential button and stuff like that, the little caret, or you might see an x square on it. If I ask you something that's related to the work we're doing with graphing calculators, I will probably give you like a picture or something like that, and ask you, what does this mean? Okay, you won't actually need a graphing calculator for your test, Mark.
When the rest of the class we're just going to go around.
No, we're going to actually go over Geogebra as well. But if you have to leave, Mark, for work, you can listen to the class video on YouTube. Oh, yeah, from the last class. Okay, all right. Thanks for coming. All right, so let's take a look at this. So here's the equation we just graphed by hand, and suppose we wanted to graph it using the graphing calculator. You first have to enter the equation, and you do that by turning your calculator on. And so to turn your calculator on, let me get this a little bit bigger here. You just turn this on button right there, and then you go to y equals. Okay, so I still have everything in here from my previous class, so let me clear it out. Okay, so you enter the equation. Let me clear it. Just like you read it, 4, and then make sure you hit your subtraction button here, because that's what that dash stands for, subtraction. Take away. Then your x is right up here, xt n theta, but you just hit that and you'll get the x. Now you can either hit square or you can hit caret with the exponent 2. And that's how you enter, and then you hit enter, and there's your equation. You always know your equation is turned on because there's a little black box on your equal sign. And you can turn it off by just toggling back to that equal sign and hitting enter, and that will turn off that equation. So if you had multiple equations in here and you only wanted to look at one, then you just make sure you have this little black box. Okay. So choosing a, so let me get a little picture of this. I should have had this camera up, so let me get this going. So I'll just take a little picture of this for you so you can see how to enter that in your calculator for later. Excuse me? Of course, you can do whatever you want. Absolutely. I was just showing you both ways. Either one, you can just hit X and then hit the square button. That's okay. Yep. All right. No problem. Okay, so choosing a window or a viewing rectangle is one of like the trickiest things to do for some functions. This particular function, it's not going to be hard. So sometimes you have to adjust the window to really get a full picture of your the graph of the equation you're trying to graph. Okay, to see its entire shape or all the important points. I keep saying function because we're going to get there, so I've got to remind myself to say equation. So if you need to adjust the window, first of all, let me just show you that the standard window that you want to try first is to hit zoom. So right now, if you hit the button zoom right here, zoom, and you go down to 6, you can either scroll down to 6 or hit the button 6, and then you hit enter. That's going to give you a particular window. And if you're really lucky, you get your graph and you can see it and you don't have to adjust the window at all. So this particular window, let me take a picture of this. This is your standard window, and sometimes it works and sometimes it doesn't, and you just got to play around, and it takes a little time. So here's a picture of the graph using the standard window right here. Let me make this a little smaller. Okay, and if you look at your window, if you go here where it says window and you click on window, you notice it tells you that the X minimum value is -10, which means the value right here, the last value to the left, is -10. It tells you your X maximum value is +10, which is out here. And then it tells you as you hop from one little tick mark to the next, it's just changing by 1, an increment of 1. So you know this is -10, -9, -8, blah, 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 down to 0. And then it's 1, 2, 3, 4, blah, 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 up to 10. Okay, that's what X scale means. Then your Y minimum value is -10 down here. Your Y maximum is 10 up here. And then your Y scale is 1. So similarly, -10, -9, -8 all the way. So this is 1, 2, 3, blah, 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 up to 10. -9, -8, -7, all the way up to 0. Okay. Now, how do we write the window? How do we write it out? How do we notate it if we don't have this picture right in front of us to look at it? And these are the types of things like when you're curious about what I might be asking on a test. If I'm not going to ask you to have a graphing calculator, what might I ask you to do? Okay. I might give you, here's what this notation is referring to. I might give you a notation like this and ask you to mark the axes for the X and Y axes based on this information. So you see here, you have 2 brackets with 3 numbers in each bracket. The first number represents the minimum X value. The second number represents the maximum X value. This shows you your X scale, the 1. And then this second box tells you Y min, Y max, and then your scale. It's all written right here for you. So at your seats, what I'd like you to do, is I'd like you to mark the Y-axis and the X-axis based on this information right here about your window. These 2 boxes tells you what your maximums and mins are and what your increments are. So just marks your minimums, your maximums, and a couple of numbers along each scale. Okay, so let's take a look at this. Someone want to tell me how I begin if I start out here? What's my X minimum when I look at this? -20. Remember, These boxes follow the same order that you write your coordinates. So the first box represents the x information, and this second box represents the y information. So this is all about the x values. This is your smallest x value, -20. This is your largest one, 20. And then you increment by 4. So it's often good to put at least the first one from either end so you can see that what the increment is. And then if you wanted to fill in like one way down here, like -4 and +4, I'll at least know that it's incrementing by 4. Okay. Then similarly, here's all the information about your y value. So that's -12 is my smallest, 12 is my biggest. And then I'm going to jump by 2. So my next value would be -10. And then if I jump down by 2 here, it'd be +10. So 8, 6, 4, 2, 0, 2, -2, -4, -6, -8. So you don't have to fill it all in, but just so that I can see what the increments are. And this would be the corresponding window on your graphing calculator that corresponds to this right here. Katie? Oh, yeah, thank you. Oh, so now I got to do that all over. Delete. So, yeah. So my y max should be 20. Thank you. Oh, right. It's not right. Thank you. 12, -12, and +12. Thank you. So let's get a little picture of that. And then that way, when you look back at these notes later on, when you're studying or your own notes, you'll be able to see what the notation looks like on the calculator window. I don't know why it's not taking. There we go. Oh, that's ugly. Cut. Let's try that again. I can always go back and throw this in. Sometimes this is working a lot smoother than it did last semester. There we go. Let's make it smaller. Woo, and there we go, right there. All right. So that's how you can do that on a graphing calculator. Now, when you were plotting this, you were able to generate a table of values. You can do the same thing with a graphing calculator. It saves you a lot of time. Okay, so let's see how we do that. So we open up our graphing calculator. To do this, press the second button followed by graph. So notice how the graph is the blue button because that corresponds to this blue button right here on your calculator. And second is a yellow button. So I've tried to color code the notes, at least what you see by color. So you hit second graph. Okay. Now you can type in any x value you want into the x column, and y will automatically. So what did we do? We went from -3 to +3 on our notes, right? Let's say you wanted to know what was the value for the y value if x happened to be -22.5. All you do here is you say 22.5 is my x value, and boom, there's your y value. So when x is 22.5, my y value is -502.3. Okay. Now the only way I can do this, or I can plug in, or I can ask the calculator, ask it, hey, can you tell me my y value for this particular x value? Is I go back to where it's called table set right here above the window. You see a little yellow notation that says TBL SET. So you hit second window, which is your table set. And notice I said start this table at -3, increment by 1. But guess what? I don't want the calculator to fill in all the values from -3 to by incrementing by 1. I want to be able to ask it. So this is where you get to toggle and say, either fill it in automatically, which if you do that, the table is going to look like this. See, it starts with -3, goes to -2, -1. It just goes on forever and ever, giving you all the y values incrementing by 1. Or you can say, no, I'm interested in a very specific value. I want to be able to ask the calculator for specific x values what the corresponding y value is. Then you go over here and you say ask. That way, when you come to the table, you can come down here and say, okay, what is the value for y when x is negative 3.7? Then it gives you the y value. So the table can be really handy if you're trying to find the solution for a particular x value. You just go in and plug it in. And you do that by putting the little switch, the little toggle right here where it says ask. Okay. All right. So I'm not going to do this, but I just want to show you how you graph the absolute value because it's a little tricky finding absolute value. So come back to your y equals button. And now we want to turn off this equation right here. So go right here, turn it off, just hit enter, and notice it no longer has a black box there. So just turn it off. And now how are we going to find the absolute value? You have to go to your math menu. Math is located right here, right below the alpha menu here, the alpha button, excuse me. So you hit math and you say, I don't see anything in here that looks like an absolute value. And that's because it's in this menu. You have to scroll to the right 1 unit to num, N-U-M. And then notice the very first one is ABS with parentheses. ABS stands for absolute value. So you hit enter. And then you just throw your X in and close the parentheses. And that's how you get the absolute value menu. Okay? So if you hit zoom 6, there's your graph, a graph very similar to what you had on your papers, but this goes from -10 to 10 because it's still the standard window. Okay? So that's pretty much the basics of how you can use your calculator to graph and generate a table of values. And you can always use the graphing calculators in the Math Studio if you want a little more help, or if you have your own, or if you want to borrow one from me, that's fine as well to do some homework. As long as I'm here and you're here, that's fine. Any questions on anything we just covered? Okay, so let's talk about how we can use the TI to do X and Y intercepts. Okay, so X and Y intercepts. Okay, I think let's go back to our Y equals 4 minus X squared equation. So I'm going to turn my absolute value one off, turn that off, and go up here to the 4 minus X squared equation, Y1. So to find my Y intercepts, I do something called second trace, and I choose option 1 called value. So I go up here, second trace. That's my calculate, and I want to find the value of y when now I enter when x is 0. So if I press 0, I hit enter, and there's my y value, 4. So I just tell it to calculate my y value. You could have also looked at the table and gotten that, right? You could have gone to the table, saw where x was 0 and what the y value was. But this is a way to get it directly from the graph. So again, you go to your calculate menu, which is second trace. You go to value, and then you type in x is 0 because you're trying to find the y-intercept. Okay? To find the x-intercepts while looking at the graph, press second trace. So this is a little different, second trace. And you go down to where it says 0. You're trying to find when the y value is 0. So you go to 0. And then you hit enter. And this is kind of a cool thing. All you have to do is kind of cursor down till you get sort of in the neighborhood. Anywhere near where the graph crosses the x-axis, hit enter, enter again, and then enter again. Oh, and I got quit. Why? I don't know where this quadratic equation is coming from. That's weird. Okay, so let's go back to the graph. Second calc, 0. Okay, so here's another way to do it. Another way to do it is to say, we know it's at -2, but all you have to do right now is throw in a number really close to -2, like -3. Hit enter, enter, enter. Why is it telling me quit? It is. -3 is to the left. I don't have to put both in. Let's see. I don't know. It keeps. Let's see what let's follow the instructions in. There's a fast way. When prompted, put the cursor slightly to the left and then press enter and then slightly to the right and then enter again. So, all right, let's do this. So second trace, go down to 0, and let's put the cursor slightly to the left. All right, here we go. We're slightly to the left, hit enter, slightly to the right, hit enter again, and there's your 0, your x-intercept. Okay. And then to do the other side of the parabola, you just scroll over, go to slightly to the left. Well, you got to go up and say, I want to find my 0. You got to tell it what it's doing. So go up to second calc, say, I want to find my other 0. When you scroll over just to the left of +2, there I am. I'm to the left. I hit enter. Then I scroll to the right, hit enter again, and there's your second x-intercept. Okay. It's written right here. You just got to follow the instructions in your lecture notes, and you'll have the video. Okay, because I really want to get you going on GeoGebra, and I can help you individually. Okay, it will come pretty quickly. Okay, once you do it a couple of times. So remember, it's all on the video. I know there's a faster way to do it, and I don't understand why it wasn't working, but I'll practice that on my own and show you on, what's today, Wednesday? I'll show you Friday. Okay. So let's get to GeoGebra. So now I don't want you doing anything. Shut your laptops and Chromebook and everything right now. Just close them down because it's too much of a temptation. So we've seen how to graph y equals 4 minus x squared by hand. We've seen how to do it with the graphing calculator. Let me show you how to do it with GeoGebra. So first I'm going to open GeoGebra. Everything you need to know right now for GeoGebra is on this handout on the back table, the yellow one. If you didn't pick it up, don't bother to get it now. But this, Caitlin wrote this for students, so when they're doing their projects, you can refer to this. Your first project is this green one, this green piece of paper. This is due next, I believe, next Wednesday, and it's all done using GeoGebra. So basically, right now, I want to show you a couple of things about GeoGebra. Okay, first you have to learn how to input an equation. So, but one thing I want to show you right away is it always starts looking like this, and people sometimes don't like to have their axes like way over to the left. If you want to move, this is called the graphics view, the graphical view. If you want to move that graph, you have a 4-arrow little button up here. You just click on that and a hand appears, and you can move this wherever you want around like that. Okay. All right. When you do this, you're going to be using this to drag any selective objects you want. Well, we haven't put any objects in here. The points are called objects. The graph of an equation is called an object, and all your objects are given a small letter like A. It's got a name, A, B, C, D. Okay, so I'm going to go down here to the input box, which is way down here in the left-hand corner. And I'm going to write in y equals 4 take away x squared. And if I type anything incorrectly, let me know before I do it or as I'm doing it. Okay, so I've typed in 4 take away x squared. I hit my enter button, and voila, there's your graph. Okay, that's pretty darn quick, isn't it? No windows to mess around with, nothing. Okay, so that's how you enter an equation into GeoGebra. All right. Let me find what I asked you to do next. Okay, so if you want to generate, so this is called your algebra view, this is called your graphical view. You could generate a table of values over here for this if you wanted to. And you do that by going to your view and saying, I also want to see a spreadsheet. That comes right over here. So in your spreadsheet, you would do something like this. You'd write in -3, -2, -1, 0, just like we had in that table that when we were plotting by hand. Okay, so you do that. Then over here, this is a spreadsheet. So you have to tell it how how are you going to calculate your y value? So you have to say equals. You got to put a little equal sign in there, and you say, I want to start with the number 4, and I want to subtract this cell. This cell is called A1. Subtract that squared. Hit enter, and there's your -5. That's a point, -3, -5. That's what we got when we did it by hand. Now, you don't have to go down and do all of these. This is the beautiful magic of spreadsheets. You just grab the right-hand corner right here, and you go like that. Voila, they're all filled in for you. Okay, that's how you would do this using a spreadsheet. If you had an individual point that you wanted to put in this particular parabola, for example, what would be the y value if x was 4? If x was 4, okay, this would be 4 take away 4 squared. So it'd be 4 take away 16, and that would be -12. So you can also come right down here and input real data like you have from your graph that you're going to use today. So you put parentheses, and you say when x is 4, comma, y is -12, comma. You hit enter, and there's the point A. So where is it on here? How come you can't see that point A, that object A? Why can't I see it on here? It's not in the window. So one thing you can do is you can just move this up, and there's point A. Now here's a nice thing you can do. You can right click on point A. You can go to object properties. This is a very important thing. And you can say, hey, I want to see the name. I want to see the label. I want it the name and the value. You go like that, and notice you get the coordinates of the point. Okay. So when I refer to the word object, A is an object. It's the point for -12. Guess what? C is an object. C represents this parabola, the equation for this parabola. Well, what a lot of students want to know is, how do I change my view? Well, with a mouse, you just scroll, right? And it makes your scales different. With a Chromebook, you use 2 fingers and you move up and down. Or you can go to your axes right here, right click, go down to graphics, and say, okay, my x-axis, yep, it's showing the numbers, but here's where your window is right here. I want my x-axis to start at, say, -10, and you put -10 in. And I want my maximum to be, I don't know, 50. Whatever scale you want. It depends. Now, when you're inputting real data, this is where you want to change your scales, because your real data may have an x-axis that just goes from 0 to 10, but your y-axis is in thousands of dollars, like the tuition and fee. So that's where you do all your changes here. So my y minimum, I don't know, might be -50. But my y maximum, I know, is 4, because my y-intercept there is the maximum point. So my y maximum value is 4. And then I hit enter. And there you see a graph with different scaling and a little different picture. Okay, so what I'd like you to do today is, if you came in late, someone at your table should have told you that there were a couple of typos, one with the equation, is I'd like you to open up Geogebra and start inputting all of the data that this bar graph represents. Okay, so the first thing you're going to do is input your data, not with a spreadsheet, but by inputting each individual point down here in the input bar.